Good afternoon, everybody. Just want to make sure my team can hear me okay.
You're good.
Excellent. Thanks, Don. Thanks for taking time out of your day today to join us for another webinar series. Today, we're going to have a bit of a team approach to this. We'll do a little introduction here in a moment, but the topic today that we're going to be covering is bridging the gap between geospatial survey and UAS, talking about collaborating across geospatial platforms and sensors and accurate data collection as a approach to a UAS type of project, whether it's photogrammetry or LiDAR. You can go to the next slide if you would. Thank you. So first of all, my name is Steve Richter with Frontier Precision. There's going to be some folks on the team from the geospatial side of our company talking about how we use some of these sensors that you see here to augment some of the UAS projects that could be done in the field. Again, whether it's photogrammetry or LiDAR. As we go through this session, we will certainly entertain questions. Put them in the questioner chat. We'll also be recording this, and the recording for this will be available on our YouTube channel after today. I would expect it'll be up there sometime tomorrow, something like that. As you can see, we have a lot of coverage in the US for different products. From the map here, our geospatial footprint involves 11 states. And then I'll turn it over to Wyatt here, who will introduce or be representing the unmanned team as they go through this presentation as well.
Thanks, Steve. Hi, everyone. Thanks for joining us today. My name is Wyatt Robbins. I'm the UAS sales manager for Frontier Precision. Our UAS team has nearly 25 dedicated UAS experts in almost 25 offices across the country. We're an end-to-end solutions provider, meaning we help any size UAS program from start to finish, offering everything from hardware sales, training and support, and proof of concept and operations. We offer ROVs underwater and below ground, mobile command centers, anything to do with UAS. We have been granted a beyond visual line of sight waiver, and we're working on obtaining another one with our remote dock operations to allow for true beyond visual line of sight operations. We have a dedicated team of geospatial and GIS experts on staff to help bridge that gap between geospatial and UAS. With that, I'm going to turn it over to Kyle Engel to get us kicked off with our webinar here.
Thanks, Wyatt. Hello, everyone. Like Wyatt said, my name is Kyle Engel. I'm the geospatial sales representative for Frontier Precision here in Montana. Going to talk a little bit about some of the equipment, software, and procedures used on the geospatial side for this project. So in terms of the equipment, we ran 2 bases and then roved with the Trimble R12i receiver paired with the TSC5 run and Trimble access. And then all of the data was then dumped into Trimble Business Center. Next slide, please. So before going out, we did want to check all of our equipment, make sure it was calibrated correctly. So in the office, I've got a jig for calibrating rover rods, made sure that the vial was calibrated there. I do not have a bench for calibrating tribracs, but with a simple field procedure, we were able to check those out. So if you're interested in that procedure, definitely feel free to reach out on that. Next slide, please. So for day 1, I just took a screenshot of TBC here, and we were focusing on the ground control with the LiDAR targets. So like I said, we ran 2 bases, one at RP7 and one at EMP 208. The RP7, we were running a RTK logging and then just static at the 208 position and roving off of RP7. So our workflow for this was 2 180 epic shots. We did one fully extended with the 2-meter rod, and then we collapsed the rod completely, took an HI measurement and did another 180 epic shot. And we also, just to keep everything systematic, we made sure that the LEDs were facing the same direction for every shot, which was a 300-degree azimuth for this project. A couple of the additional EMP shots were provided to us as already existing control, so we also did that procedure on those just to double verify our work. Next slide. So for day 2, I got a screenshot here in Trimble Access focused on the ASPRS shots, which Bob is going to cover a little bit more in depth on that new procedure. But same procedure as day 1, 2 180 epic shots, 2-meter fully extended, 1 fully collapsed, and then you'll also see a couple V shots. They're the vertical shot, hard shots that are just below the dam there. So again, just to verify those. And from there, I'm going to go ahead and pass it along to Colin.
Thanks, Kyle. Yeah, so my name's Colin. I oversee Montana, North Dakota, South Dakota for our UAS or unmanned portfolio. So yeah, I was out in the field with Kyle on this project. I do want to mention as well that this is a 2-part series, so we're going to go over kind of hardware and how we got to the end result, but we'll have another webinar here in January covering more of the data as a whole. We will touch on it today, but just want to make that note. First and foremost, on the UAS LiDAR hardware side, we did this in both photogrammetry and we did it with LiDAR as well, kind of doing a comparison between the two. A lot of hype in the UAS or even the survey space on aerial LiDAR. So we wanted to take an approach and kind of look at both sides of that coin. The sensor we used is actually the YellowScan Voyager. This is based on a Regal 120 sensor. Each manufacturer has their own IMUs and such that they put into them. So ours run an Implanix AP20. We can also get an AP50 in there. Implanix, for those of you that aren't familiar with them, this is actually a Trimble company, so there is Trimble hardware inside of there. But this is the best aerial LiDAR unit you can get in terms of the UAS platform. So we'll be running about 1.5 million points per second with those precision and accuracies you see on screen there. One other thing I do want to note on it is this is a PPK workflow. So as Kyle mentioned, we had 2 bases set up running 1 hertz or recording 1 second static. And that will be used in the UAS side to refine the trajectory of the flight. This is, as I mentioned, the biggest, baddest UAS sensor that we can put on a drone. And that gets paired with that big bird you see on screen there, the FreeFly Alta X. This aircraft tip to tip is probably about 4.5 feet to 5 feet. So it is a large aircraft. That sensor weighs about 8 pounds. So it does require that heavy lift platform in order to make it work. We did use the blue version in this scenario. If you're not familiar with blue, it's a security standard in the place of the DIU. And really this blue version, we get lots of questions about this, but blue really is only needed for certain scenarios of critical infrastructure. One thing to note with blue version UAS platforms is they don't have quite the capability in terms of camera sensors and such. So keep that in mind. And then we also do our flight planning with Alta Q ground control or Q ground control, which is pretty well known across the UAS industry, and I believe I do have an image of that here on the next slide. One other thing I do want to kind of point out as well. So we'll talk a little bit about it, but aerial LiDAR we can colorize, but we do have a majority of folks not colorizing their LiDAR data. So it comes out in either like an intensity view or an elevation view showing us different colors, and you'll see that here in a little bit. But I do want to kind of point out our LiDAR targets specifically, just so that if you're looking at getting into the LiDAR world, that you have that notice that you do need a specific target. Down in the bottom right there, you can actually see one of our targets in TBC in that intensity view, and that's how we'll be able to pick those points that Kyle shot and reference that to the LiDAR data. Next slide, please, Dylan. So as I mentioned, we also did some photogrammetry on this. We used a 20 megapixel camera from Yellowscan. So this is an add-on that can be used. I do want to note as well that LiDAR and photogrammetry both use different overlaps. So we did have to fly this mission twice because photogrammetry uses a higher overlap than LiDAR will. This is an independent camera, so it is taking photos completely separate from the LiDAR data itself, and we'll have to mesh those together later on in the processing side of things. But we can use these cameras to colorize that LiDAR data. So if you wanted to see the road is gray and true color, that's what this camera mod is intended for. Next slide, please, Dylan. All right, so as I mentioned, flight planning, a few things that we did in this flight plan. The Voyager is, as I mentioned, the highest end that you can get for UAS. So the parameters, we were able to fly higher and faster than we would with most other sensors on the market. So in this scenario, we ran this mission at 20 miles an hour at 400 feet. So the sensor is actually rated to be able to put on an aircraft as well. So 400 feet was well within range of that laser to get us all the way down to ground. But that should be noted that depending on what you're flying in any scenario, you may want to adjust according to the sensor. On the right there, this is Q ground control. This is all able to be mission planned either on a desktop or on a controller if it's applicable to it. The standard Alta won't have, well, it actually does have now, has a new controller that you'd be able to plan on it, like you see on the screen. But pretty straightforward flight planning. You're able to import KMLs or just, you know, with your finger drag and drop a certain box to your parameters. On the left side of the screen there, you will see the Alta X. You can kind of see the massive size of that unit and give you kind of a good scope of how big it is. Next slide, Dylan. So I did want to talk a little bit. There seems to be where we see the biggest gaps is definitely in the software side. It gets confusing for folks. How do we get from the data that I just collected all the way into Trimble Business Center or into a useful format that we can actually design off of or create different deliverables out of. So on the left side of the screen, you'll see a Planix. As mentioned before, this is the IMU in the unit itself. That is collecting static data on the actual LiDAR sensor while we're flying. We'll have to, there's kind of two routes to do this now. Cloud Stations actually integrate this all in there, but we can either go into a Planix's software and refine that trajectory, or we can just automatically put that into Cloud Station, which is Yellowscan's processor, and it'll automatically refine that trajectory for you. On the left side of the screen there, that's a screenshot of the project with Cloud Station. Every LiDAR manufacturer will require a specific processor in order to get that data out. In this case, again, it's Cloud Station from Yellowscan. One thing I do want to note that's fairly impressive about this sensor, again, we were flying at 400 feet. If you look at the trajectory lines on that left flight there, you see the light blue. We're still roughly 400 to 500 feet away from that power line, and we were still able to grab power line with this sensor. So just kind of alluding to how powerful this sensor is. But to continue on, from Cloud Station, we would get our basic LAS out of that, be able to check all the data that you see in the field, and then we would move over to Trimble Business Center, where we would plug in Kyle and the survey folks' side of their data into that to bring it all in together to one mesh. All right, next, Dylan. All right, and then just a couple more references here. So again, we flew photogrammetry and LiDAR. This is just kind of a side view of the photogrammetry data that we received from this. Again, pretty good clean data there. With photogrammetry, you will see some different blurring just from it not being able to depict elevation, especially in vegetation. You'll get kind of a clumpy clumpy group of vegetation in any capacity. You can go to the next slide, Dylan. Thank you. And then this would be LiDAR data. This is still, full on LiDAR data. There isn't any classification here, and we haven't, taken away any of the vegetation. But this is really where LiDAR shines, is it's able to penetrate through that thick vegetation all the way to ground, so that when you want to take away that vegetation, we are getting true ground out of that data. And from here, I will pass it on to Dylan. Or Bob.
Actually, I think it was going to, was it going to Bob?
I think Bob.
Yes, indeed. I'll be next. I'm Bob Green with Frontier Precision, title of Geospatial Analyst, and I'm a licensed surveyor as well. So I help out working between manufacturers, customers, looking at needs, and also applying survey principles. And that's kind of what we're going to go through here. And I don't want to bore people with a bunch of statistics, but in order to create a foundation, there are, as you can see at the top, entities that have been in practice of creating standards for a very long time. I remember as a young surveyor back in the 70s, we had no technology, okay? So if you want to know the angular relationship between 2 points, you set up a transit, which was a modified protractor with a telescope and alidate attachment. You had a steel chain, or we call it a steel tape, and you had a tension handle and a thermometer so that you could adjust for coefficients of expansion. And that was the standard. However, in the late 70s, we got a hold of a HP Hewlett-Packard distance meter, and that distance meter shot distances electronically. And so people started using that until entities, in this case, it was the Massachusetts Land Court, that said, hey, we need a check. We can't trust these distance meters. So on a given survey, you were required to measure with a steel tape, just like you would have, a series of baselines in order to compare. And it was an eye-opener for me as a young surveyor, the difference between precision and accuracy. You've seen the same thing happen when RTK came out. The same things appeared where people were using RTK, and if you were trying to sell a customer that product, the first thing they would do is set up their total station with an electronic distance meter and shoot between those RTK points as kind of a proof of concept. Now that UAS has kind of been unfolding, I mean, I remember working with Tony early on 4.5 years ago. We started to build our team. And now that this whole industry is kind of blowing up, entities like ASPRS on the photogrammetry and imagery side are starting to get involved in tightening up requirements and making people aware that, if you want to meet these particular standards, you have to do X, Y, and Z. And that's what we're going to go through here. On my portion, I'll be talking about our control, both on day 1 and day 2, that Kyle touched on. Also looking at some of the network adjustment results, because according to ASPRS, which will be hitting heavy on session number 2, I have to meet certain requirements. We'll go through that. I'm also going to show some of the simplicity in TBC of relative tolerance reporting that's now been available for ALTA standards, another set of requirements, more focused around title when title is changing, especially on commercial property of what they require. That easy button, as I call it, is not yet available for ASPRS, but I'm hoping as we move forward that will happen. I'm also going to touch on precise point positioning, or PPP. Trimble's RTX solution is a PPP solution, and how it is now endorsed through ASPRS, and they have an entire section, Section D, on workflows in order to be compliant with PPP technology. And then I will end my portion talking about some affordable GIS mapping hardware solutions that can get down to centimeter accurate that I'll explain more in depth. But it's a great way if budget is an issue and all you have to do is collect ground control, a workflow that is fairly inexpensive. And I've done quite a bit of testing with the product, so I can validate that, and we'll look at some options there. Next slide. And I have a lag too with my the slides popping up, slow internet. Anyways, here is the data that the customer supplied us with for this proof of concept. So legacy data going back in time, used for monitoring and other geospatial or geodetic applications. So this here was supplied by our customer. Next. I'm not seeing that slide yet, but the there we go. And like Kyle mentioned, we had 5 main control points. Keep in mind, this is PPK, and the benefit behind PPK is that we can do forwards and backwards processing. So with RTK, you get a position at an instant in time. With PPK, we can take that forwards and backwards. And so, and we don't have to worry about data link. That's a given. The only downside to PPP is that you don't know if you really have a good answer until you process it. But other than that one fact, I find it in all of my testing, partnered with the UAS folks, to be a superior product because of that forwards and backwards redundant processing. We had 5 main control points. Keep in mind, since we have PPP or PPK, excuse me, everything is relative already through that PPP engine or PPK engine. And we only had about 35 acres. So this is not a huge site. So we use 5 main control points, and that's what you see here from our day 1 survey ground control activity. And as Kyle mentioned, in accordance with the ASPRS Standards of Edition 2, which just got released back in late August, early September, following those principles, they were redundant measurements off of a single base. The second base down there to the bottom right was logging data so that I could also process static analysis between those 2 base points as a redundant check and incorporate that into my network adjustment solution. Next slide. And I don't know if Kai or if Colin mentioned it, but that material that we used on those panels was geared for LiDAR, and that's why those panels showed up so nicely in that interface that he displayed. First of all, if you're a Trimble user, this will make sense. If not, you can talk to your manufacturer about what you would need to do to be compliant. But when I set up my survey style to collect this data for my ground control, I make sure, since I'm going to run through a network adjustment, that I log QC data, and QC2 is the component that carries my statistical unbiased data, which is in Trimble's world VCV, variance covariance, but in the academic world covariance matrix data that will be used in the network adjustment. There is a QC1, QC2, and QC3. QC3 is great for people to log if they're not going to adjust data, because it gives error ellipse components and northeast and up standard deviations on tangent plane and all that kind of good stuff. So anyways, that's just kind of prepping of what Kyle and I did before we went out in the field setting up the survey style. Next slide. Once I download into Trimble Business Center, one of my very preliminary things that I do is take a look at the spreadsheet, the vector spreadsheet. This kind of gives me a lot of pertinent data. Ironically, you can see kind of down halfway to the middle, we had some exfil observations. That's because we went into a hole and we're using UHF. So Trimble exfil was able to be applied. And at my final result, I disabled one of those and enabled the other. But anyways, we're able to get an observation on the point that we wouldn't have been able to get without that exfil component. I'll touch on this here in a couple minutes as we go through the presentation. This also gives me all of my, keep in mind, I did all my work at 1 sigma. So some of the slides that you say, well, typically I would do that at 95% confidence level. I'm not to that point in this survey. So everything is at a standard deviation of 1 sigma. Next slide, please. And those vector spreadsheets are kind of nice too, because you can put them in Excel format and they're easy to work with. On day 2, Kyle went out by himself and he set up on that second base point that you can see down there to the bottom right. And he tied back into those 5 control points so that we had redundancy to work through our network adjustment on that primary control. And then he also captured some checkpoints. And those checkpoints consisted of ends of stripes in the road, identifiable entities that we could use as checks to be compliant with the ASPRS Edition 2 standards. And I think he got a little over 30 of them. I believe 30 is the minimum. Plus he got some of those vertical only ones that he put into the loop as well. And those were redundantly shot, 2 different HIs, 2 different RTK initializations per the standards. Next slide. Now we're going to get into looking at all of that data within Trimble Business Center. And you can see now I have redundant baselines into my main control. And I want to do this for a proper network adjustment. Least squares works much better when you have redundancy. One thing I did learn about this, and I'll maybe touch on a little bit more, is I did this with RTK, and typically, if you were to ask me 5 years ago, would you do a control survey like this with RTK? I would say no. It would be all static, baseline processing, old school. But I'm kind of changing my tune, because on these smaller projects and proof of concept projects, I got incredible results, which I'll talk about more here in a minute, but pretty amazing results with strictly RTK as a driving force behind this portion of the survey. Next slide, please. And again, that was in Trimble Business Center. A lot of what we were looking at before was in Trimble Access. Here's my finalized at least 1 sigma network adjustment. And you can see my Aerolifts components there off to the right are ridiculous. They're like 0.5 on average. So really quality data that we're able to get with strictly RTK. And I think a big part of this is Trimble's ProPoint engine. And Trimble came out with ProPoint, which replaced HD GNSS. And the whole theory behind ProPoint is to remove noise. Any Trimble users or even other manufacturer users will notice that they get RMS values. In Trimble, it used to show up on the upper right-hand side, RMS components, which were relative to 19 centimeter wavelengths, So if you take milli, 19 centimeter wavelengths, do the basic math, 60 was high RMS. Well, they now absorb that RMS data, that left-hand circular polar data, and throw it out of the solution. So we get much cleaner data when we're out in the field, and we're witnessing that right here. So the Trimble ProPoint engine, I think, is part of the key to success, and part of the reason I'm thinking of in the future of considering this. It's just the size of project that I'm questioning. Naturally, if I'm going to tie into cores, which I didn't have to, this was that was another kind of thing I had to think about. Hey, this is existing control. It was given to me by our customer. All we have to do is validate it. So I didn't have to go out to core stations. If I did, however, static would probably still be my answer. Next slide. Now we're going to look at here the more of the intricacies of the network adjustment is. But before we do, one thing I thought that I would show would be the amazing results that we got when we combine quality survey with a quality LiDAR sensor like our YellowScan Voyager. And what this is here, it's both our control and some of the client's control. And this is rendered classified ground data. So this is all ground. Keep in mind, this was a dam or an earthen or earth-filled dam. So there was vegetation on there. And each one of those little circles that you see, the icon, half of it is sticking up and half of it is below the surface. Now, keep in mind, this is rotated at about a 45-degree angle. So that's telling me, I mean, naturally, if all of my data was below the surface, you wouldn't see those points. If it was too far up, it'd be right in the air. But we're cutting hairs at sub-centimeter, working with some of this control. And this is cleaned up, classified ground YellowScan Voyager data that to me is mind-blowing, that we can get that close with part of our proof of concept of being, can we use this workflow for monitoring of dams and other infrastructure, especially in areas which are hazardous, life and limb, that you don't want to get up on, high walls on highways and things of that nature. So next slide. And we will, on our next session as well, look at the classified ground data relative to photogrammetry as well. In my network adjustment, I'm just going to hit the basics. I'm not going to go through a deep statistical dive. We just don't have the time. But I have my local site settings, and I can tell from this is truly a ground coordinate system with a proper scale factor. So that one thing I know. I get lots of questions. Our support AGE team, probably one of the biggest questions that we get in the industry from end users is, on scaling projections to ground. And if they are, and this is one way that I can tell, and so that's why I exploded this, just so you kind of see it. Next slide, please. Also, it gave all my pertinent parameters for this local site that we're working on in the background, tied to state plane, but truncated and localized for that work area. Also in my network adjustment, we're looking at error components, and these will come into play in our ASPRS reporting. Keeping in mind, these are projected grid coordinates, and relative to our control network. But look again at the error components. I'm looking at, on average, 6-7 thousandths. I mean, we're millimeters, and all through a proper network adjustment powered by good survey practices out in the field with our R12 and R12i equipment. Next slide, please. Again, another set of errors, and I just want to point out here is as we move forward in technology, and that's what I, as a geospatial analyst at the company, I do a lot of research, and AI, as we move forward, is not going to understand projected coordinates from mathematics from Gerardus Mercator 454 years ago, or this is Lambert. So those parameters were created in the 1760s, about the time musket balls were flying through the air during our Revolutionary War. AI is not going to care about that. It cares about these Earth-centered, Earth-fixed coordinates that you see up here on the screen. They are a true ground coordinate relative to the equatorial plane. And I believe in the future, and not so distant future, we will be working with these more and more as things move forward. Then below that, we have the converted ECEF to adjusted latitude, longitude, ellipsoidal height coordinates that people are more used to working with. Again, these slides don't show the full data set. I couldn't fit them on the screen, but look at the errors associated with those heights. They're right around 100th, and that's on the vertical side, which is worse. All of this data is in US survey feet. If I was doing it scientifically, I would have done it in meters. But since this was for a proof of concept and a presentation, then I kept it in survey feet. Next slide, please. And then we have error ellipse components, our covariance terms, our precision ratios. You can actually get these, not the equivalent, but like I say, if you log that 2C3 in your data collector in Trimble Access, you have error ellipse components of the measurement itself. So that's kind of also good to have on board. Next slide, please. And importantly, to kind of wrap this up, we have our, in our adjustment, our standardized residuals, or the residual divided by the standard deviation or standard error, then put into graph form as shown down there in the bottom right in a histogram. Histograms are mentioned in the ASPRS standards. There's some images of them. If you go to page 60 in those, I believe it's section B, you'll see where the reference to histograms is. To me, on a scale of 1 to 10, I would give that about an 8.5. You can see in the center there at my sigma, I don't have a spike that I would like to see in there, which is making me consider possibly next time I do this type of proof of concept, I might also double tie in my checkpoints, because I included them in the adjustment. Even though we shot them twice, we only did it from one location. But overall, I have no tau outliers and very good data. And keeping in mind that all this was powered through Trimble Business Center, all the data that you've seen so far in Trimble Business Center. Next slide, please. And now we're getting to kind of the easy button where we're going to eventually be able to take, I hope, a lot of this statistics that I've been talking about, and behind the scenes, Trimble and manufacturers will probably simplify it as they have done with ALTA reporting. There is an ALTA allowative relative tolerance report, and you can see there it's pretty cut and dry. It's a button press more or less in reports to let you see if you are compliant. Keep in mind, I am at 1 sigma. ALTA does require 95%, but this is strictly for proof of concept. So, which is kind of nice about this report is it is configurable. So if you ever run across certain tolerances that you need on a particular project, you can configure them in this report. Next, please. And starting to wrap things up here on my side of the fence is looking at Trimble's real-time extended service, which is a PPP, precise point positioning deliverable. What this feature does is it allows you to get centimeter accurate positioning anywhere around the continental United States. Now Trimble says 2 centimeters, and their statistical reporting is in RMS. We use DRMS and whatever. But at the end of the day, if you keep your receiver out in the field for a minute, you will get that 2 centimeters. And if you keep it out there for about 3 to 5 minutes, it goes half of that. So you actually, traditionally with an R12i Trimble Access, I'm getting about 3/100 horizontally by 7 to 8/100 vertically. And so because of the advent of these PPP solutions, and Trimble's not the only one to have them, that are becoming more and more popular, especially because you don't need cellular. You can have it, as it shows on the left. There are 2 deliverables with RTX. One is through L-band satellites that are that broadcast down to your receiver in the field, and you can also use a cellular link. So for instance, if you have a lot of canopy around, cell might be better if you have it, where L-band, it's better to have at least some view of the southern sky. But I did proof of concept on this on a job from the Mexican border up to the Hoover Dam back a couple of years ago, and it's actually featured in an American Surveyor article from last year, I think, called Real-Time Certainty. So if you want interested, you can look that up. But anyways, this is taken off and is eventually over time probably going to take over, you know, some of the VRNs, and the VRNs are going to start offering more accuracy, and it's just going to keep moving forward and forward. Next slide, please. And I've done a bunch of testing with Trimble RTX. I think another differentiator is Trimble's ability to incorporate a deformation model, meaning seismic activity. And we use the same one that's on the NGS website, the HTDP model, horizontal time dependent positioning. And that really is a separator that we account for that. I wish I could go into all the details, but I don't have time. But that is a game changer. If you would like to try a 30-day trial of Trimble RTX, it is available if you Google it. We also have available Xfill Premium service. So if you're an RTK user and you occasionally run out of UHF or data link, it extends the 5-minute Xfill component to unlimited. So that's kind of a cool feature. I believe we have some on our on-demand website, some more material on that if you're interested. Next slide. And I'll end with kind of this here, talking about a very inexpensive app. It's $10 called UAV Ground Control. It's a Trimble app. It's for Android only, and its focus is for locating ground control points. Interfaced with a number of receivers. You can use it with your R12, or you can use it with a DA2, which is shown there in the off to the side. It just gives you latitude and longitude. So it doesn't, latitude, longitude, and height, it doesn't give you stay plane, but you can bring those into your software of choice. It does export a spreadsheet. So a $10 app coupled with a $400 or $500 antenna, you can generate. Naturally, you're probably not going to meet ASPRS standards, but that doesn't apply to every job. So it's a very inexpensive solution in order to collect ground control, or actually anything that you need to locate that's single point, right? So if you had a job and you needed to locate water valves or hydrants or whatever, it would work for that application as well. Next slide, please. Here we show the options. You can get it with a pole, a monopole, and depending on the accuracy that you need, we have various subscriptions through Trimble Hub. And what's cool about Trimble Hub too is you don't have to get a year, right? So you can get a day, you can get a month of data. So it's kind of keeps your budget, if budget is an issue, and you have a drone, this might be a way forward for you to transition. I've done testing with the DA2, and it does work very, very good. It's not anywhere near as compliant as, say, a R12 or an R12i, but it does get the job done in a pinch. Next slide, please. Then I think that I am going to be turning it over to Dylan to talk about some deliverables or precursor to deliverables that we will be generating on our second webinar. We'll be doing a deeper dive into the ASPRS standards, along with deliverables from Dylan of Linework, and then surface comparisons and a whole bunch of good things. So next slide, please. And that'll be in our session 2. The date isn't formally set, but probably mid-January.
Yeah, perfect. I think I can take over from here, Bob. So this is Dylan Jones. I'm out of our Maple Grove, Minnesota office. And just to quickly mention a couple things there, if you're someone that's totally new to Trimble Business Center or network adjustments, baseline processing, things like that Bob was talking about there, Trimble has some relatively new and very informative webinars on their webinar website that go over things like network adjustments and how to do those using Trimble Business Center. So check those out. Usually just Google Trimble Geospatial Webinars and you'll find the vault with all the webinars there, as well as Frontier Precision on-demand training. I know that Bob's done a network adjustment and baseline processing workflow is among a bunch of other on-demand training courses, and that website is training.frontierprecision.com. So check out those resources. And then I'm going to take you through, this is going to be more of a teaser for next session. So if you're someone who is looking forward to, how to use this LiDAR data to create some deliverables, perform measurements and things like that, that'll be in the next session, but I want to give you a glimpse at just some quick examples here before we wrap it up for the at the end of the day here. So this is just a quick video showing in Trimble Business Center that Voyager LiDAR data. And this is not colorized to RGB values, but to the intensity. You can see that control point there and the target with that intensity value really making it easy to find. Doing a quick measure distance there to measure from the control point to the center of that target. It was about, it was measuring in at about 6/100ths vertical, 6/100ths of a foot. Now we're going in and taking a look at just a quick little limit box of that dam and the bridge road that passes over the top of the spillway there. It's crazy how detailed that LiDAR data is on those wing walls and whatnot, and providing you all the necessary data in the point cloud to perform your Linework extractions and build a nice looking surface model. And this is just repeating now, so I'll go to the next slide. So here, just a quick zoom in here, looking at the LiDAR point cloud with that target panel and what that looks like in the LiDAR data versus what you would typically see in a photogrammetry scenario when you're doing your GCP corrections there. And then we take it into a process, and a normal process for me is gonna look something like this. And everyone has a different process, so this isn't the end all be all by all means, but I typically will take my point cloud and perform a classification to extract what I need as far as classifications go. So here we're looking at the brown being the ground extraction, and then the rainbow color just being really everything else. So that could be vehicles, or that low vegetation, high vegetation, really whatever else there might be. And in the latest release of Trimble Business Center, you're going to find some really neat classification tools and the ability to train your own classification model. So what that means is if there's some custom assets or objects that you want to classify in your point clouds, you can train the software to detect those using AI. So another tool that I would recommend using here that's relatively new is called advanced filtering. And so this is going to allow us to get down to that bare earth or the lowest points in the point cloud, allowing us to really eliminate the grass and other vegetation that there might be. And so a quick little snippet of what that tool looks like, where you're going to input a point cloud and filter out and get the minimum elevations. It's kind of dividing up the point cloud into a series of cells and grabbing the minimum elevation point, and a little snippet of what the resulting point cloud looks like after that. So we really shaved away a lot of that low-lying vegetation and other objects above the ground. And then from there, it really gets into the drafting side of things and your line work extraction, things like that. A wide variety of tools out there. You know, in TBC, there's some automated extraction tools that can do things like grabbing curb and gutter, paint lines and guardrails, things like that, to do things a little bit faster. But it also might come down to just manually extracting with clicking of your mouse. And so this here is just showing our ortho photo. And sometimes in my workflow, I actually use the 2D ortho photo to extract line work. From the photogrammetry or the ortho photo, it's very easy to see the objects that you're looking to extract. Some objects you might not be able to extract, but some you would be able to. And so in this small section of this project area, just something that a lot of people are going to be familiar with are these roadways or intersections. And what I ended up doing is spent a little time extracting some line work. Nothing too crazy there, but you can see the line work that was extracted. And that was using the ortho photo. I then used a command that allows me to drape those 2D lines up to the point cloud elevation. So that's where I basically said, take these lines, drape them to my LiDAR point cloud, okay? And that's a relatively new command as well, called drape objects on a point cloud. And so now I ended up with 3D line work, and might be a little difficult to see with the black background there, but the point cloud's displaying, and then I have my 3D line work there on top of it. So I really just draped my point cloud down, or up, I should say, to my point cloud elevations. And then also in the next session, we're going to talk about creating surfaces using the advanced filtering algorithm to get bare earth and build a surface model. You can see the cattle guards there on the crossroad going north-south there, just the points that were captured through the cattle guards and things like that. But and also cleaning up surfaces after they are triangulated, go through some of those tools. I also want to touch on profiles and cross sections. So this is just a quick cross section of the point cloud from the top of the dam down to the bottom. And on the next screen, a cross section of that spillway, or whatever you want to call it. So being able to use these cross section type views to extract important points or break lines, whatever you might be interested in extracting. Of course, this could apply to a wide variety of applications. And then deliverables, whether you're looking for a 2D plan sheet like what you see on the right there, just being able to put all your line work, the ortho photo, put it on a 2D plan sheet and export that out as a PDF, or using 3D PDFs. I don't know if anyone here has dealt with those before, but 3D PDFs are pretty neat. You get to see your actual surface and line work in 3D and hand that off to someone that can open that up and actually see the 3D data, all in a PDF format. So very quick teaser there for you. If you're looking for some additional information and more of a workflow process in detail on the extraction side of things, that's what we'll do in session number 2 in January. Now let's see if we have any questions. I know we're getting towards the end of our session time limit here, but did anyone have anything? Again, if you do have questions, feel free to just type it out in the questions or the chat, and we'll get to those. Oops. Okay, we do have a question. Maybe Bob, this is something that you can answer. What was the reasoning for only doing a minimally constrained least squares adjustment is the question. Is there a reason why you do a minimally constrained versus something different there, Bob?
Yeah, the reason we did it is I wanted everything relative. So the point that we first occupied, and we based pretty much the survey on, was not on the dam itself. The rest of the components were on the dam, so we wanted to look for movement. So I didn't want to constrain to a second point that could be in compromise. So that was the reason. And I always start out minimally constrained, because if I have issues there, there's no sense moving it forward. But that is a good question. Typically, I would constrain it to multiple points. But for this analysis of monitoring, I made everything relative to that single, I think it was called RP7 there to the north of the dam, not on the dam itself.
One thing for me, just, listening to Kyle and Colin and Bob speak here today is I'd like to know some of the ins and outs of the new standards that were released. And I think that's something that we could do in session number 2 to start, if that isn't already in the plans, just kind of bullet point what the new standards are. And, is there a recommendation or a requirement for a network adjustment, things like that? How do you report those out exactly? So, any other questions? I'm not seeing any other ones come in, so hopefully we did a good job of explaining through our mindset there. And if you do have questions to follow up with, feel free to get in touch with any one of us here on this webinar. And then Bob and Steve, do you want to do a quick conclusion to end things here?
I'll let Bob go ahead and do that. I'm sorry, I got to jump.
Yeah, thanks everybody for attending. I think you're going to start seeing more of this out of Frontier Precision, kind of a breaking down that barrier between the disciplines of UAS and the teamwork that went into this through Colin on the UAS side and Kyle on the geospatial side and my oversight. I was out in the field on this, by the way. So I think we're going to start seeing more of that, and I look forward to session 2, where we'll do a deep dive on workflows that are associated with ASPRS and go from there. So thank you very much for attending.